And yes, I know that I have the answer here, but when you think about it, so first of all, we need to understand what homogeneous is. Homogeneous is if you have a mass, okay, and then if you do one scoop from that mass, you're going to get some mass and some volume, right? And if you do two scoops, you're gonna get twice as much of the mass and twice as much as the volume. So the homogeneous means it has the same density. Okay, that means the molecules in the object is distributed evenly everywhere. So if that's true, then it's easier to find the geometric center by using the symmetry. So it's like if it is 6 by 6 by 1, then you can just find the center of this object and geometrically, right? And that will be also the center of mass. So the homogeneous cases are gonna be much easier. And we can use this fact that we know the center of mass for basic shapes to find the center of mass for more complex objects. So here's an example. We have some sort of a U-shaped object, and we want to find out the center of mass. Again, the center of mass doesn't have to be at the center of the object, first of all, and or on the object. Okay, I mean, it can be outside of the object, and as you can see, we'll find that out. So how do we do that? Again, if they were nice rectangle pieces, then we would find the geometric center right away. So what do you do if you have a rectangle? So first thing is, this is some sort of a U-shaped object, but we can split up into 3 pieces. And once you do that, so this is our first piece here, right? I want to highlight it. It's a rectangle, and what I need to do is I need to combine the diagonals, and then find the point, and that's the center of mass of geometrical center. That's also the center of mass of that piece. And doing the same thing for the others, and this one too. And you can see that those intersect at the center of mass point. So this is how we figure out where the M1 is condensed for that first rectangle, and M2 is for the middle one, and M3 is for the last one. Okay, so they're like we are just kind of saying that the total mass is divided into 3 pieces, and we do assume, unless it is told otherwise, this object is homogeneous. And the next thing to do is, okay, I can see the center of mass of the first piece, but where is it located? So I'm going to draw lines, and I'm going to call them x1 and y1. Same thing for the m2, x2 and y2. And for m3, it's x3 and y3. Okay, so this is on the Cartesian coordinate system, x and y, so you're finding the positions. And since this lies on xy plane, then that means maybe there was no z component. But if it had a thickness, then you would also find out what the z component as well. So then what you do is next, you can do one at a time. You can do only the x components first. And so once you see this, I just want to show something quick. So, okay, I have 3 pieces, and I'm just going to find out what x1, x2, and x3 are. I found those positions, then I write my x center of mass. What I'm going to do is I'm going to multiply m1 with x1, and I'm writing that right here, plus m2 x2 plus m3 x3, divided by total mass. Again, that total mass is simply m1 plus m2 plus m3. Okay, and I'm going to do the same thing for y. Now I'm going to kind of ignore the x. So for m1, this is y1, m2, this is y2, m3, this is y3. I'm multiplying those. Again, you have to be consistent. m1 times y1, it's not m1 times y2 or y3. And we are going to add those terms to get y center of mass. Okay. And once you get those values, what you see is, okay, this is what I found as x center of mass. This is what that is. And this is what my y center of mass. Find that point and then you're finding your center of mass point. It turns out it doesn't lie on the object, and it's perfectly fine. So what is the strategy that we follow? And again, I want you to keep this in mind so you can apply it to the examples. First, you look at the shape. If it is not a simple geometrical shape, then break into simple shapes. So you can find the center of mass the way I showed, if they are rectangle or there are some other shapes that you also know where the geometric center is easily. And then find center of mass of each simple shape, and then using the center of mass equations, find overall center of mass. Okay, that's the plan. And it is possible that center of mass for the overall object may not lie inside, again, as I've been saying. Another example would be a donut, whose center of mass will be at the center of the interior hole, but there's nothing in there, right?